Hey there, Emmanuel here from WebDevFuel, and in this video we're going to continue building upon this data dashboard with Go and HTMX. More specifically, we want to add a form along with validation that happens on the backend, and then using templ and also Go, we'll be able to add here messages based on the requirements of a particular form. In this case, if we give this form a try, this is going to be the end result by the end of the video, along with slow 4G enabled here. As you'll be able to see, we are going to make here a request, so we'll click here on new user. We'll be able to see here a loading spinner while the request is happening, and also the button will be disabled while the request is happening. And after the request comes back from the server, we see here this message that says that the field is required for all of these different fields. And if, for example, I went ahead and changed this to a value, so for example, let's say that the status is active, and we then make a request, it is going to go to the backend again, and it is going to send the HTML partial, and using HTMX, we'll be able to insert this again here, now without the validation. One of the benefits of doing things this way is that we only need to specify the validation in the backend, and it is always consistent. It means that we don't need to have some kind of validation on the front end and either be forced to use JavaScript on the backend to be able to duplicate that same validation logic. And I think it is a much better experience in the end, because something goes to the backend, we check if the rules apply, if it is required, if it is something duplicate, for example, or not. And then we send that thing back to the end user, and I think that end users in general understand that's the case. There are a lot of validation rules that cannot happen on the front end. And also another thing is that in terms of security, this is much better. There are a lot of cases where people use JavaScript front-end frameworks, and that is not really a fault of the framework itself, but rather of the developer. But what ends up happening is that someone implements some validation logic on the front end, and then they simply forget to implement it on the back end, and it ends up creating a security vulnerability. So with this being said, let's hop into the code. We're first of all going to take a look at how to implement validation logic with Go. Then we'll see how to set up the templates and how to then handle the request so that we can replace here the form after it gets validated. But before we continue, if you want to learn more about how to build web applications with HTMX, Go, and PostgreSQL, then go to webdevfuel.com/hgsb or click the link in the description down below. The first thing we want to do is install a package to allow us to have validation using Go in a simple way. We want to avoid implementing all of the logic obviously from scratch, and to be able to have a nice API to do validation with Go, we'll be using the validator package from the Go Playground project. And I'm also going to leave a link in the description down below so that you can take a look at this GitHub repo. But essentially, we want to copy here this command to be able to install it. One thing that is important here is we want to install here the version number 10. And after copying this inside the root of our project here, we want to paste this, and it is going to download the latest version and install it. Now let's take a look at this validation.go file. We need to create first of all a validation directory, and inside of it a validation.go file, something very simple. Inside here we want to specify the package name, which will be validation. And then we need to add the following things. We first of all want to add a form error struct, where we'll be able to have the field, a message, and also the value. The field is going to sort of be the field name or ID, and then the message is going to be the error message, which can either be an empty string or not. And then the value in this case will be any. We're not really going to, in this video, handle all edge cases when it comes to, for example, arrays or different kinds of types that might be sent via a form. We're going to stick with something very simple, a string, and later we could implement something a bit more complex. But to accommodate for those changes in the future, we want to add this thing as any. So the value is any. Then we want to also add here sort of a type alias for a slice of form error struct. So this is going to be the form errors. And then we want to append a bunch of different methods or functions to this type alias here to be able to do things with a slice of form error. So at a particular moment in time, we're going to have access to a slice of form errors, and then we want to be able to look for things inside of it, also get information to essentially know if an error exists, if a field exists, and those kinds of things. We have, first of all, this one has field. It is attached to the form errors, and then it takes as an argument the field, which is a string, and it returns a boolean. So it simply reports whether this field exists or not. We initialize the boolean as false by default, and then we range through each one of the form errors, and if the form error.field equals this one, then it means that we have a match, and we can say here has equals true, and we return the value down here. This is something very simple. We want to loop through each one of these form errors, and if the string that we have here matches each one inside our slice here based on this field, then we want to return true. Then we also want to add this other function that will get the message. So we want to have the ability to specify the error message, the validation message, and we want to be able to extract this inside of a template. So we'll pass here the field again, and in this case, we'll be returning a string. We initialize here the message as an empty string, and we then again loop through each one of the form errors, and if the field matches, then we'll say that the message equals form error.message. Both of these are sort of helper functions to essentially allow us to interact with this inside of our templ components. And then we get to the part here of getting the value itself. One thing that we have here noted is that we can implement other values, other value types in this case. For example, a number, a boolean, slices, and other kind of types. For now, we are going to keep this simple. In this case, we get the value. Here we got the message, and now here we do basically the exact same thing. But because the value is of type any, for now we want to do the following. We'll be doing here an initialization of the value with the type any. Then we want to range through all of the form errors. And if the field matches, then we want to say that value equals error.value. And after doing this, we want to check here and see if this is of type string. If that is the case, we want to return the string itself, and if not, we're going to return an empty string. The additional logic that we could add here would be to, for example, check and see if this is a number, and then return the number inside of strings, or if it is a boolean and either return true or false inside of strings, because usually when we get these values inside of an HTML partial, we want them to end up being strings, even if the type that we are handling here is different. But again, for now, we're going to keep things simple, like they are here. And then we have here the message. This is a very simple helper function. It is not attached to anything. We simply want to pass here a tag. So these are the tags that the Go playground validator package is going to sort of generate. And for now, we only want to implement one type of error message, and that is the required. So we are going to switch based on the tag. And if it is required, we'll return the message as field is required, like you saw previously here. If we hop back into our UI, we have this message here. And if not, for now, we're going to return an empty string. We could have other kinds of validation rules. So for example, the length of something, or it being, for example, present in the database or not, something like that. But for now, we're only going to implement the required rule here. And then we have here this function that will allow us to initialize a new validator.validate. If we take a look at this, it is going to be imported from the package that we've just installed. And here we want to, first of all, initialize a new validator. We're going to say here with required struct enable. And then we want to register the tag name function. In this case, we want to keep things simple for ourselves, and we want to have a key inside of the tags of our struct fields, where we say form and then we specify the key of this form field. So for example, if we were to have something like the name, and we inspect this really quickly, as you can see, we have here the ID and the name of name. In this case of the email address, we have email for both of them, and we want to have the ability to specify these keys essentially inside of the structs. And to keep things consistent across this package and also the package that is going to parse the form, we want to only specify these ones. So we are going to tell here the validator package that we want to look for this tag. To accomplish this, we're going to use this line here. We are going to split this, and then we want to look here for the form. So this is the field. This is a struct field that we'll be grabbing using the reflect package that essentially allows us to inspect Go code. And then we're going to get here the tag. This is of type, like it says here, struct tag. And then we get this thing here. Get returns the value associated with the key in the tag string. And then we want to check and see if this is a dash. So usually the convention in Go is to add a dash when we want to ignore, for example, a particular field, whether that's when marshalling and unmarshalling JSON or using databases. So if this is a dash, then we want to return an empty string, and if not, we'll be returning the name. So here we essentially are registering here this function that will be running each time that it looks at a particular struct field. And then after initializing this here and registering this, we can return this down here. So the type that will be returned is validator.validate. Now we have this default function that essentially will allow us to initialize a set of form errors in a much simpler way inside of our templates, and that's because we'll have a form that is first rendered on the initial load of the page, and in that case we won't have any kind of errors, and to avoid having to do this manually, we want to have a simple way of doing it in the following way. And we finally get to the last function inside of this file. This one is the function that will parse the data that we have available to us. And it is also going to take a look at the errors that we get, or in this case that we pass into this function. And it is going to return a pointer to the form errors, which again is an alias to a slice of form error. We start by first of all initializing the errors, and then we want to grab here the value of using the reflect package. So this is going to return a value. And then we also want to grab here the type from the value that we've initialized here. Then we are going to range through each one of the fields that we have available to us, and we'll grab here the field and also the value. So here we are going to have essentially a number of different fields, and we are going to do here a raw loop inside of Go, and we want to essentially ensure that we are looping through each one of the fields. So it is going to start at the first one, and if this I is smaller than the number of fields, it is going to stop looping through. To be able to grab the field and the value, we need to pass the index into both of these methods. So we say here type.field, and then we are required to pass here an int, and here for the value.field we do the exact same thing. And then we want to append here to the errors a new form error, and we are going to say that the field is the value that we get from the form. So we are going to say field.tag.getForm. This is similar to what we did up here. And then we want to also pass the value. And to be able to accomplish this, we are going to grab here the interface. This is a method that is provided by the reflect package, which essentially allows us to return the underlying value as an interface, and later we can check and see what the underlying type of it is. So essentially here we are going to loop through each one of the fields and putting the information here. One thing that is important to keep in mind is that at the moment we still don't have any kind of message put into here. So that's what we want to do next. Down here, we want to do a for loop, and we want to ensure also that this error is of type validator.validation errors. So the error that we pass into this function essentially can be of quote unquote any type, and we want to do here type conversion to ensure that it is in fact a type that is provided by the validator package. So for each one of these iterations, we'll be getting here the field error from the validator package. And then we want to also, inside of this loop itself, do another loop where we'll be ranging through each one of the errors that we currently have now available to us, since we've appended here each one of the fields essentially here as a form error. And after we do that, we want to check here and see if the field matches. So if the error.field, and we need to call this function, equals form error.field, then it means that we have a match between both of the fields, and they essentially match on the form tag that we specify inside of the struct. And now we want to initialize here a new form error. It is going to in fact replace the previous one, but we can do things this way to keep things simple and easy to understand. And here we'll be assigning here the field, the exact same thing that we previously had, so the thing that we had up here, and then we have the value, and finally we want to generate the message by passing the tag into it. So if you recall, we had this very simple function that takes in a tag, which is a string, and then if it is required, we want to say here field is required, and we could again also in the future add different kinds of things. By doing this, we then have here a form error available to us, and we want to simply overwrite it based on the index. So we are going to extract information from the error, and then we are going to overwrite it with these new things, including here the new message. After doing this, we want to return here a pointer to the errors. We could do this entire logic in a slightly different way, but the reality is that it works, and instead of, for example, having a method that would override the message, for example, I think that doing things this way is simpler, not only for us to understand later when we read the code, but also since we are trying to learn this thing here, and I think it keeps things simple. Now we want to hop into our templates, and let's see how we can use this entire logic to be able to render a template, not only on the initial render, but also after we make requests to the backend. But before we continue, if you want to learn more about how to build web applications with HTMX, Go, and PostgreSQL, then go to webdevfuel.com/hgsb or click the link in the description down below. Inside the user.templ file that is inside the view directory, we have here two different templ components. We have this new user that is going to be wrapped around a base layout, and we'll be using this for the initial render. It's going to be very simple. We want to say here new user, and then we want to initialize a new user form, and we'll pass the validation as default. Like I said previously, if we want to refresh this page here, by default, it is going to have no errors, which means that we want to render the validation as default. So we'll be using this simple function that we've created previously to be able to accomplish this inside the template without adding a lot of noise here inside the template itself. And then this calls the new user form template, and it is this one here. We're going to pass the errors, which is a pointer to validation.formErrors. And then here we'll be doing the common HTMX and form things. So we want to add a form. We want to say here hxpost. We'll be posting to /users each time we create a new user. Then we specify here the swapping strategy, our HTML, meaning that we want to replace the entire form. We also have here the indicator, meaning that when this thing is making a request, we want to find the first element with the ID of spinner inside of this element itself. So it is going to look inside this form, and when it finds an element with the ID of spinner, it is going to know that it is the indicator. And then we also want to disable the element, but instead of disabling the form, we want to also find the first button inside of this form and disable it. and this is only going to happen again each time that the request is being made to the backend. Then we have here our labels and our inputs. So we have here the label attributes. This is essentially a way of adding CSS classes. If we take a look at this, we have here the templ attributes. We specify a class and then we say what the class is. And by spreading this thing here, so if we take a look again where we were previously, so we were here. So if we spread this thing in the following way, then templ is going to take all of these keys and all of these values, and it is going to add them here as attributes. Then we want to specify the ID that this label belongs to, in this case, the name. So we say for, and then we say here name, and each time that we click on this label, the input is also going to be focused, and it is good practice when it comes to implementing forms in the browser. Then we have the input. In this case, we also want to spread here the input attributes to be able to add a class. The difference here is that we want to call this function to be able to render different kinds of classes based on where we are using the input. In this case, we are using it inside the form. We also want to be able to use it in different parts of our web application, and to have this reusability, we do things in the following way. And then we specify the value. Now we get to the part where we actually get to implement the validation. Here we say errors.getValue, and then we pass the name. One thing that's important to keep in mind is that the value that we grab here is quote-unquote the default value. So if we were to go back here to the browser and we specify here a name and we submit this thing, as you'll be able to see, all of the validation rules are included here, but we also have the default value here inside of this input, meaning that when a user submits this thing, the values that the user already has submitted are not going to be lost. That is something very important. And then we specify the ID and the name, both of them also name. Then we say here that if the error is different than nil, so since this is a pointer to validation.form errors, we need to check and see if this is different than nil. And the errors has the following field. So if it has the name field, then we want to add here a span. We also add here the error attributes to show this with the color red, for example. And inside of it, we pass here the message. If it is going to be an empty string, then we are not going to see anything here. And if that's not the case, meaning that the error exists, then we are going to see this thing. So if we come back here to the browser and we inspect this really quickly, as you can see, it still renders this span here, but without any content, since when it tries to get the message for a particular error, it doesn't find it. And then we do the exact same thing also for the email and also for the status. The email is more or less the same thing, so we're going to skip over this part. But then we also have here the select element. In this case, we also want to add here the following classes by using this function, and we then specify here the default option, which is an empty string with, so we need to specify the value, which is going to be an empty string. And then we do the following thing. By using templ and using the following syntax, so if we add here an attribute and then we add a question mark, and we then add some kind of logic here inside of the curly braces, templ is going to hide this if the result of this is false, and it is going to show it if the result of this is true. So it essentially means that it is going to hide this select thing if it is false and show it if it is true. So by doing this, we can get here the value of the status and then see if it is active, and if that's the case, it means that this one is the selected one. We pass here also the value, that's also important, and the label, and we do the exact same thing for all of the other ones. And by doing this, when we submit also here the form with, for example, this active status selected, after it gets back from the browser using HTMX, it is going to be inserted here, but we're going to still preserve here the value that was previously selected. And then we also want to do the exact same thing here, see if an error is present, and show it if that's the case. But before we continue, if you want to learn more about how to build web applications with HTMX, Go, and PostgreSQL, then go to webdevfuel.com/hgsb or click the link in the description down below. Now that we've taken a look at the templates, we want to see how the handlers work. First of all, we have this very simple handler that is essentially going to do the initial rendering of the user of the new user page. If we navigate here to this, as you can see, it is the exact same thing that we saw previously, and then we want to render it using templ. And then each time that we make a request to /users, we are going to use the following code here. We want to first of all initialize here a new user form data, which is going to be a struct. And then we want to add here all of our fields. First of all, the name, which is a string, and we want to specify what the field name is. Again, we are going to use the form key here inside of the struct field to be able to specify the field name. In this case, we want to say here name. We also do the exact same thing for the email and also for the status. And all of these three different fields, we want them to be required. So we specify here the validation logic that is then going to be interpreted by the validator package. It is going to know that we have this thing here, and it is going to do the validation, and then we can pass those errors, those validation errors, into our function. Then we have this form package, which is also a part of the Go Playground project. And if we take a look here at the documentation, installing it is also pretty simple. So let's copy this command, and here inside the root of the project, we want to install it. And now let's restart the program. And here, essentially what is happening is we want to specify, first of all, here a decoder outside of our handler so that it can reuse or essentially cache the results. And as a result, it is essentially going to be a bit faster to do things here when it comes to decoding forms. We want this to be a pointer to form.decoder. And then we have the function itself, or the handler itself, that is going to allow us to create a new user. Here we are going to take as an argument the response writer and the pointer to the request. Then we want to override this decoder by saying here decoder equals form.newDecoder. And then we want to parse the form. So we are going to use here this parse form method that is attached to the HTTP request, and it is going to parse the form so that we can use it and decode it using the form package. After doing this, it is going to return an error, and we want to check and see if it is different than nil. And then we want to initialize here the data. So we'll be initializing the struct that we've created up here. And after doing this, we'll be using the decoder, and we want to say here decode. The first argument is going to be the thing that we want to decode into, so we are going to pass here a reference to the data. And the second argument is the form. So since we've already parsed the form, we can say here r.form, and it is going to allow us to decode this correctly. We also want to check and see if this error is different than nil and do an early return if that's the case. And then we finally get here to the part where we initialize here the validation. So this is imported from our internal package. And if we take a look just to recall, it is going to initialize a new validator, and it is going to also add here this function to register a tag name based on a different field tag. After doing this, we want to do here v.struct. And by doing this, it is going to validate a struct, expose fields, and automatically validates nested structs unless otherwise specified. So this is essentially a function to be able to do the validation. And then if this error is different than nil, meaning that we have some sort of validation errors, then we want to pass here this into the validation.errors function, which is again going to look at all of the fields, and it is going to match between the fields, the values, and also the message. And then we are going to get back here the form errors, which is a slice of form error, and then we want to pass this into the new user form component. So we want in this case to only return back to the browser this partial. And after doing this, we are going to render this thing here. And we can also do here an early return. So let's say here return. And if we don't have any kind of error, then we want to generate a new UUID for our user. And we are going to insert the user into the database by passing here the data.email, the name, the status, and also a timestamp when the user was created. And we're going to execute this thing. And then we're also going to add here this thing that allows us to essentially insert this user into mainly search. So we want to grab the index, then we're going to add here documents. And the way that we add documents is by passing this thing here. It is a slice of maps where the keys are strings and the values are any. And we say here ID is the ID, we pass the name, the email, and the status, the exact same thing. So essentially what we want to do here is we want to insert this user into the database so that we can query it in particular situations. And then we also want to add this user as a new document to the mainly search instance so that we can look for it in a more performant way later using, for example, our table. Then we're going to check and see if the error is nil and do here a log if that's the case. And finally, we get to the point where we actually want to send a notification back to the browser, letting, for example, another user know that a new user was created. And we're going to also redirect the current user to the user's page. So if you take a look at the previous videos around this web application, this data dashboard using Go and HTMX, we went over how to add notification using WebSockets, and here we're going to take advantage of this. Now let's give all of this a try. So let's navigate to the new user form page. And here, let's say, for example, hello@webdevfuel.com. I'm going to keep the name the exact same thing as the email address. And then we can also say here active, or in this case, I can actually delete this and say that the name is only webdevfuel. So now let's create here the new user. And then if we were to search here for webdevfuel, as we'll be able to see, we now find this new user that was just created, and we had all of that logic to be able to do the validation. And the cool thing about this tech stack is that it also enables us, as you saw, to send real-time data to the browser using HTMX and WebSockets. So we have here a split open, we have the form, and also here the dashboard that has this feed. And if we were to create this, as you can see, we now also have the ability to search again for it here inside of the list, but we also have this thing here inside of the feed to let other users know that an action was just taken inside the web application. As you can see, it is pretty simple to do validation and to submit forms using HTMX, using templ, and doing all of the validation using Go in the backend, which I've also said at the beginning of the video, but it makes things much easier since we don't have to have the duplicate logic of validating on the front end and then on the backend. With this being said, I hope this video was helpful to you, and I'll see you on the next one.